Hi, this is Shuqi, Sophie, and Minji. This is our project Stylistic Melody Generation given chord progression. Stylistic music generation is to generate realistic music with predefined styles. It has aroused a lot of attention from various areas. However, it is hard to generate both creative and natural music. Current models link music structure information, especially for deep learning models. It's also hard to include music domain knowledge. Generate stylistic music given chord progression is a fundamental problem in this topic, since they are the basis for almost any piece of music. Chord is a combination of several notes. Here we consider the 7 diatonic trichords in each major scale, represented by a vector of integers from 0 to 6. For melody, we consider the diatonic scale in 2 octaves, together with the staters representing the rest note, and use 16th notes as a minimum note length. Thus, we can represent the melody use vector of integers ranging from -2 to 14. Using previously mentioned notation, our music generation problem given chord progression is expressed as follows.
Our state in MCMC is a tuple containing the pitch, the duration of this pitch, and the corresponding chords. We maintain a table of conditional probability distribution of selecting the next pitch and its duration for each state, and modify it to decrease the loss. For each episode, we can thus sample an entire piece of music state by state based on it if we have seen the state. Otherwise, we use the default uniform distribution. After many episodes, our result conditional distribution should become better, and we generate the result pieces by sampling from it. We can thus pick the ones with the highest overall ratings and compose section by section. For each state we have just sampled out, we modify its distribution to select the next pitch and its duration. For each of the possible choice observed, we add epsilon times the difference between its expected accumulated loss and the minimum expected accumulated loss among all possible next choices. The accumulated loss is calculated by the weighted sum of the instant loss for this state and the losses of other sequential states after taking this state and choice in the trajectory. We take the average of the different accumulated losses we have seen at different times to be the expected one.
We design a statistical cost function to calculate the loss. It is based on both music theory and statistics extracted from the input seasons, including the following functions with respect to a variety of melody style features. In the generation step, we use 3 more long-term rating functions to pick up the best generated melody. Let's look at some examples. First, there is a relationship between note length and pitch interval size. The statistics analysis from over 1,000 folk songs shows that if the notes are shorter, the probability for the smaller pitch intervals will be higher, and if the notes are longer, the interval size will on average become larger. Also, this figure shows the pitch and beaters of over 4,000 folk songs in major mode. Notice that the songs are rather short excerpts. As the song became longer, the beaters will probably rise a bit.
Here is a plot of the average loss for each episode. It is average of 10 experiments, which has 10k episodes each. The blue line is the average loss for every episode, and the green region is the standard deviation. From the trend, we can see the loss is continuously decreasing as we have more episodes. We also compare the effects of choosing epsilon in the same setting, which determines how much to modify the distribution every time. In general, the loss is smaller when we have a bigger epsilon, meaning a better result when modifying the distribution with a bigger step. But there is no significant improvement after the epsilon already reaches a big value such as 0.1.